So let us now consider another problem on a method of section. So this time we have here a truss, bridge truss, which is loaded as shown. We have 600 horizontal. So this time we will be having a horizontal force, and we have here 400 and 1000 pounds at E. And I think we should have an additional force here at D. So of course, the first step before we are going to have the section, let us consider solving the reactions. We have here a vertical RC because this is just a roller. Horizontal reaction at G along X, RGX, and its corresponding Y reaction at G. Obviously, this is 600. And then we now note of the unknowns here. We have member BC, member DF, and I think this should be CE. So member CE. So those are scattered unknowns, BC, DF, and CE. So for BC, we are going to have a section or a cut section involving BC. So a cut section AA will involve here AC, BC, and BD. So this is the first cut section. So we also have a cut section for CE. So a cut section BB will involve the both unknowns DF and CE. Okay, so before we proceed to our analysis, of course, essential to that is the reaction, the reaction of course. So we take moments at G in order to solve for our RC. So we have a counterclockwise negative times 20 or times 60 plus a clockwise 600 times moment arm of 20 minus 600, this one, times 30 plus 1000 times moment arm of 20 plus the reaction RC clockwise times moment arm of 40, and those are all equal to 0. So we have RC equal to 1250 pounds. So likewise, we take moments at the other support. We have summation moments at C. We have the counterclockwise negative 400 times 20 plus 600 times 20 plus 600 times 10, this one, plus 1000 times 20 less this one, 40 RGY. Then we all equate it to 0. So we compute RGY to be equal to 750 pounds. So we are going to check these two reactions whether it will yield to 0 considering the external forces along the horizontal. So we use summation forces vertical is equal to 0. So we have here the three downward forces, 400, 400, 600, and 1000. We add the upward reaction, 1250 and 750. Will it yield to 0? So it is really yielding to 0. So therefore, our reactions here are correct. We'll now proceed to the method of sections by considering first our section AA. So here is the cut section. So there are three sections that has been cut here. We have BD, BC, and AC. Solving BC, we just use equilibrium equation along the vertical because BD and AC has no vertical. So therefore, it will only involve BC. But first, we have to determine or assume directions for all of these cut members. Say BD is tensile, I'll assume BC to be compressive and AC to be a tensile force. So by this we can say that BC shall involve its component. So when we talk of components, we need to determine the slope of our inclined member like BC. So as we can see here in the truss, there are similar slope for these diagonal members. So all we have to do is to name the horizontal and vertical forces here. So we have horizontal and vertical here. So if this is 20, so this should include the half of this. So therefore this is 10, 20. So in short, we will be dealing with one horizontal and two vertical, and the other will be square root of 5. So having that one, we'll just place it here. So going back to this equation, we are involving here the vertical. So the vertical slope is 2. We just divide it by this hypotenuse. We have 2 all over square root of 5 of BC. This is an upward force. We deduct here the 400 going down, and that will be equal to 0. So computing this one, we have BC yielding to positive value, which is 446 or 447.21 pounds. So if it is a positive value, therefore we have correctly assumed the direction for BC, and it was assumed to be a compression, therefore this is really in compression. So we're gonna place that on BC. Okay, for the next unknown, we have DF and CE here. So therefore, a cut section BB would involve here CE and DF for the next round of section analysis. So illustrating our section, so we have here the section. We place the forces. It involves 1000 here. This is actually point E. RGY here, which is 750 at point G, and then 600 here as the horizontal point or horizontal force at point G. We have this as F, so that this is DF and that is DE, and this is CE. So we need again to assume direction. I'll just assume CE to be a tensile force here, DE to be compressive, as well as DF to be a compressive. So we are solving actually for DF and CE. So solving for DF, so we just need to intersect DE and CE at point E. So therefore we are going to take moments at point E. We note here the distances. This is 20 feet and this is also 20 feet. So therefore this is a clockwise DF times 20 less 750, this reaction, times moment arm of 20. So and all the rest have no moment arm with respect to E. So it just involves two forces here. So this is now equal to 0. So therefore, we have obviously values. The value for DF is a positive 750 pounds. And then the orientation, we have yielded to a positive. So we have correctly assumed DF to be a compressive orientation. Okay, so finally, we now proceed to the other or the last unknown, that is CE. Okay, so solving CE will just have to intersect or find the intersection between DE and DF and take moments at that point, and that point is obviously point D. So summing up moments at D, we have a counterclockwise moment CE plus this 1000 times moment arm of 10. So where did we get 10? Here it is. It is actually the half of the total DF leg of 20 less 750 times 30. So where is 30 here? So this is it. So the half of 20, that is 10, plus 20, that is 30 feet. So this is the moment arm of 750. So we less 600 times 20. So here. So all of this will be equal to 0. So solving for CE, we have equal to 1,225 pounds. So again, we yielded to a positive answer. So therefore, our assumption is correct for this tensile CE. So we're gonna place that. So this completes our solution for this second problem. So thank you again for listening.